But anyway, just starting us up, if you're interested, if you want to know how climate change, water pollution, and nutrition are interlinked, and how each of these relates to irrigation, then you are in the right session. Otherwise, there are some other session options out there. Can irrigation and water resources management be blamed for Delhi inhabitants, so New Delhi, losing an average of 6 years of their lives? Can irrigation and water resources management be a force for good to stem malaria that is projected to grow as a result of increased insecticide resistance and climate change? Those are some of the questions we are interested in here. Traditionally, irrigation managers focused on crop yields and food production and/or how to use water more efficiently. And I think we've heard a lot on that already today. However, with climate change and growing natural resource scarcity, irrigation managers have to increasingly deal with water variability. They have to deal with competing uses, with uses that are more profitable, more valuable, and that are growing faster, such as urban and industrial uses. So things have become a whole lot more complicated for irrigation management. And now, as an additional challenge, we have the SDGs. So the global community has agreed to achieve a whole range of development objectives and also planetary health objectives. And how we manage irrigation can either contribute to achieving these objectives faster, or it can lead on a bad pathway so that we cannot achieve many of these development goals. So things have become a lot more complex. And as this is an afternoon session, I will not increase this complexity, but will just look at different pieces of the complexity. And specifically, as you can see in this graph, we'll look at 3 of these interlinkages. The first one is climate change and health linkages, and maybe how irrigation can mediate between those two. The second one is water pollution and health and nutrition linkages, and of course irrigation probably plays a role there. And the third one is irrigation nutrition linkages, and you have already heard in the previous session that Martha Mamo is going to talk about that today. The premise of this session is that a better understanding of the interlinkages can help us to avoid some of the negative consequences that irrigation might cause, either for ecosystem health or for human nutrition and health. And it might also help enhance synergistic effects, allowing us to achieve many of these multiple goals that we have all signed up to with the SDGs. And I hope at the end of this session, you'll all come away with at least one idea on how we can manage irrigation differently to achieve multiple objectives or to reduce negative feedbacks that we might otherwise incur for some of these development objectives. So this is the only complex graph or slide, and this is just to show you that linkages between water and nutrition and health and food security are multiple. So I think we're all aware with the food security concept. It's about food availability, access, stability, and utilization. Irrigation has a role to play on all of these. It can improve the availability, the access, the stability over time, and the utilization. But at the same time, water is also linked, also has an issue about availability. It's affected by climate change. It varies over space and geographies. Access is a big challenge. Quality is a growing challenge, and stability as well with climate change. So between water and food, we have all these activities. So irrigated crop production, rainfed production, we have fisheries, livestock. We also have processing and of course preparation. And then we have a lot of return flows, how water comes back after irrigation into the for the next irrigator downstream or for ecosystem health. We can manage that, and how we manage that will affect downstream agricultural production, but also downstream wash services, so water, sanitation, hygiene. So we can do a better job improving the wash environment, or we can do a not so good job in making things worse off. And that's our traditional picture, but once we bring nutrition and health into this picture, we have to go a little bit beyond food. We also have to look at the two pillars that matter for nutrition. And those are the environment around the home. So that is the wash environment. Do we have clean drinking water? Do we have a good sanitation environment? If we don't have that, we cannot achieve the nutrition objectives. Instead, we might have more diarrhea, more morbidity, and more childhood death. The third pillar is care. So the care of children that women implement. And we can only do that if women have time availability for childcare. So that's the third pillar of nutrition that is also affected by irrigation. Because if we put more irrigation in place that increases women's time use in agriculture and takes their time away from childcare, we might actually have worse nutrition outcomes for those children. So it's very important to consider when we put irrigation in place, who is benefiting from the irrigation and who bears the time cost of the irrigation. So moving forward, on the third and on the other linkage, climate change and health. So it's a very broad topic. There's a lot of work being done. And this is a very basic scheme of how climate change and food systems are linked down to nutrition. But again, irrigation plays a role and can play a role in alleviating the negative impacts, and it can strengthen the positive impacts. So here for production, you can see under climate change, we have more heat and water stress, pests and diseases, lower yields and lower nutritional value. If you put irrigation in at the right time, the right amount, we can reduce those negative impacts, and we can strengthen some of the positive impacts. The same on the storage side. We have mycotoxins, we have food waste. We can help address some of these challenges through better water management, including through better irrigation management. Of course, not all of them. Storage has a lot of other issues that need to be addressed. Climate change is increasing food prices, so there's a lot of work out there. If we use water management and irrigation management appropriately at the right time, allow food to move across countries, we can reduce some of those food price shocks that are expected and are already occurring with climate change. And finally, on the consumption side, as I've already mentioned, the intestinal nutrient absorption and the safe environment around the home is important for consumption and utilization of food. And again, how we share irrigation water resources with domestic water resources, and if we pollute the water or if we ensure that it's clean for those domestic uses, will have a big impact there. There are basically 5 linkages between irrigation and nutrition and health. So the first one, that's the traditional one we all work on, which is food production. We produce more food, we produce more diverse food with irrigation, for example, vegetables and fruits, irrigated fodder, so we can improve child nutrition that way. The second path is income. It's also a traditional pathway. It doesn't really matter what we produce, but we generate a lot of income. So it could be cotton or chat or whatever. We use those expenditures, we use the income to buy health services, educational services, whatever, and we improve child nutritional outcomes that way. The third pathway I've also already introduced. This is the safe environment around the household. Again, you can improve nutrition outcomes that way. The final pathway I've also mentioned is women's empowerment. So it's very important to consider time use, but also empower women through irrigation technologies, for example, through ownership or ownership over the produce, not necessarily the irrigation technology. But there is another pathway where we have to focus on reducing adverse impacts and hazards, and that is the water pollution side. So these are some basic projections of changes in water pollution levels as a result of both climate change and increased food demand. And what this shows is that climate change is a very big, has a very big impact on how future nitrogen and phosphorus pollution loads will move forward. And basically the message here only is it's basically an increase across most scenarios, with some variation depending on the type of climate change scenario and the type, obviously, of severity of the climate change, because we do see some interregional trade to address some of the challenges, but the increase is happening everywhere. The absolute levels are obviously highest in Asia, but the increase, the growth is fastest in Africa from low levels. Finally, water pollution and health. How is it linked? This is just one example, linkage of salinization with some of the diseases for Bangladesh from the Global Burden of Disease study. So salinization in irrigation water and in drinking water is linked to heart disease and stroke and also to maternal disorders. But Bangladesh and many other countries face a whole bunch of water pollution and water contaminant issues. And so this is just one. If we overlay all of them, we can actually link a whole bunch of disease, human health disease factors with contaminants in the water. So it's something to consider if you move forward. So to conclude, those are our global health risk factors, the key ones. I believe that the first 7, 8 can all be at least positively addressed through managing irrigation differently. The same for our global key development challenges. Poverty, undernourishment, lacking safe drinking water, energy. If we manage water and energy and irrigation differently, we can address a lot of these global development challenges. And the same for our ecosystem health. There are a lot of linkages with agricultural water use for terrestrial, freshwater, and marine biodiversity. Again, if we manage things differently, locale specific, we can do a much better job. So the key takeaways are that we have much more responsibility for irrigation management going forward, giving all these drivers and threats. Irrigation can really do a much stronger, much larger job, a much more positive force for the good. But achieving this requires cross-sectoral coordination, cross-sectoral data collection, and the willingness to do things differently, to adapt irrigation to these new challenges. So going forward, we have a few more speakers who are actually doing some deep dives. I just helicoptered on top, but we now have some deep dives, starting with Jesse Bell, who will talk about the role of public health in dealing with drought. Then we have Martha Rhoades talking about water pollution and health, and finally Martha Mamo talking about nutrition and irrigation linkages. And this will be followed by some panelists, and will introduce everyone in turn. But just quickly, Jesse Bell is the Claire M. Hubbard Professor of Health and Environment at the University of Nebraska Medical Center. So each of our speakers has no more than 10 minutes, and I will cut them off. So it's a promise after 10 minutes. Thank you. Thank you very much.
Is there a...
Yes, there is.
Okay, good. So first off, I'm going to actually talk more broadly about climate change and the impacts that it has on public health, especially in the agricultural communities. So in 2016, there was a report that was released from the White House that I was one of the lead authors on that looked at the impacts of climate and climate change on human health here in the United States. And what we found was, and there's a number of findings that came from that report, but the two main findings that I want you guys to draw from that report is that climate change is a significant threat to the health of the American people, and that all Americans are vulnerable to the health impacts associated with climate change. And the reason we can say that is all the ways that, one, our climate is already changing with more extreme weather, rise in temperatures, changes in CO2, and changes in sea level as well. And those things have direct impacts on our environment in some capacity. And you can see all the different relationships that are here. And those changes in our environment have direct impacts on our health. And there's a variety of different ways that that impacts our health across the United States and across the globe as well. So this is another way of looking at it. This is a pathway showing how we get from the climate drivers, or changes in our climate, down to the human health outcomes. And it's basically just taking that big circular spinny wheel that I just showed and streamlining that. And so up the top we have the climate drivers, then next we have the exposure pathways, the environmental changes that we're experiencing because of a changing climate, and then the health outcomes that are associated with that. And one of the things that I really want you to focus in here are the gray boxes on the outside. Those are the social and behavioral contexts and the environmental institutional context that influences that pathway. And that's really important because that's what our communities look like, that's what our populations look like, that's what our people look like. And that's how we either get an increase in human health outcomes from climate change or a decrease in outcomes from climate change. And so by social and behavioral context, we're talking about age, gender, race, ethnicity, access to healthcare. And by environmental and institutional context, we're talking about what's the environmental change that's occurring in those areas, what's the agricultural systems look like, what kind of livestock that's being used as well. And so when we're talking about the impacts that climate change has on human health, there's a variety of different ways that that influences our health and influences that agricultural system as a whole. And this is just one of those pathways kind of illustrating some of the potential changes we get from the farm all the way to the table as far as influencing food production and food consumption. And so one, with increasing temperatures and changes in precipitation extremes, we can see potential impacts on our crops, potentially more pathogens. They're being exposed to new areas and earlier emergence of those pathogens, which means that we could see increases in agrochemicals in a lot of our farms and fields, which means more exposure for both the people that live in those areas and for the people that potentially are eating these foods as well. Then with rise in CO2, we've seen that there's been a sharp decrease in the nutrient concentration in the crops that we grow. We've actually seen decreases in protein concentration or protein availability in the foods that we eat, and also the nutrients just in general. Warmer temperatures can result in food spoilage, especially as we start to transport those foods to different areas. And then as we see extreme events, we can see potential impacts on actual access to that food and disruption of food to the people that are trying to consume it. So those are some of the potential health impacts or some of the potential impacts from going from, again, that farm to table. But now I want to talk a little bit about some of the impacts that that climate change has on agricultural communities and especially the people that are out in these rural areas. And so first off, extreme heat. We know that in the United States, we've already seen an increase in extreme heat events. They're increasing in frequency and intensity, and they're expected to increase into the future as well. Extreme heat has a direct impact on human health all across the United States, everywhere from Philadelphia to Chicago to here in Nebraska. Anybody that's detasseled corn has probably experienced that in some way, some capacity. And again, agricultural workers are definitely one of the forefront of being impacted by this. And we know that extreme heat here in the United States kills more people than any other climate or weather-related disaster, even more than hurricanes and tornadoes. Air quality. And we know that climate change decreases air quality with a decrease with more wildfires, smog, pollen, dust, mold in the air. And that has direct impacts on anybody that has respiratory issues or anybody that's outside working in some of these environments. And we know that that matters here in Nebraska because Nebraska has one of the highest death rates associated with asthma in the United States. We're actually around 6 of all states in the U.S. And then extreme weather. We know that extreme weather has been getting more intense and more frequent, and we know that in the future, extreme weather events are going to continue to get more intense and more frequent. This is going to cause injury, displacement, and potentially death for those that are in the pathway of these storms. And there's a number of people that are impacted, but again, agricultural communities are generally in the pathway of a lot of these events because their livelihoods are based off of the land itself. And not only with a change in extremes being more frequent and intense, we can potentially see these events occurring year after year. And here's just one example here in St. Louis where they showed that one of the driest years on record, 2012, which many of you in Nebraska would remember this, was followed by one of the wettest years on record in 2013. And so when these events occur back to back, it can be very disruptive to not just the communities, but also to the people that are trying to make a livelihood off the environment around them. And Nebraska, again, I'm a little bit Nebraska focused being here. Nebraska is definitely facing some of these issues. This recent flood that we've experienced here in Nebraska was the 14th flood-related disaster to strike Nebraska in the last 10 years. That's tied for 5th of all states in the United States for presidential disaster declarations. And so flooding is definitely an issue that we face here in this state and then also across the globe as well. We've seen increases in flooding. And one of the things, you know, we saw the devastation that happened to the rural communities here in Nebraska, but one of the things that we shouldn't forget is the potential mental health impacts that these events have on farming communities. And that can trickle down all the way to the children and to the people that are living in the communities themselves. Because you think about the destruction that happened where you lose your livelihood or you lose your farm, and then the potential ripple effect that that can have that may take weeks, months, or even years to potentially manifest. And typically in these rural communities, they don't have access to health care that maybe some of our urban environments do. And then also the spreading of disease. Here in Nebraska, we're definitely aware of this, with West Nile being one of the highest prevalence rates in the United States. But with higher temperatures, changes in rainfall patterns, and disruptions of ecosystems, we're being faced with more of these types of issues as we're moving forward. Again, Lyme disease and West Nile is definitely two of the major issues that we're facing. West Nile being here, but Lyme disease on its way. And agricultural communities are definitely susceptible to that because ag workers are the ones that are outside dealing with some of these issues and being exposed to some of these pests. And so Lyme disease in Lyme disease in the United States, this was in 1996. We can see the number of cases that was across the U.S. And then this is in 2016. And what we see is a pretty dramatic spread of Lyme disease, and we see it moving more across the United States. And one of the things that's been associated with that change and that spread has been a decrease in temperature, an increase in temperature, especially an increase in winter temperatures and some changes in precipitation as well. And so public health has a lot of responsibility and a large role in trying to address and deal with some of these issues. We're at the forefront of trying to tackle some of these issues, and there's a lot of work that could potentially be done in the public health spectrum as far as trying to understand the impacts of climate change on our populations, but also making sure that our populations are prepared for the next time that these events occur, and educating our people so that they're better aware of the potential health threats that they're facing. Again, climate change is something that we're already facing today. This isn't something that's 25, 50, or 100 years into the future. The impacts are today. We've already seen changes in much of our climate system. And so, in summary, climate change is a significant threat to our health. All populations are vulnerable, but certain populations are more vulnerable. These costs are increasing, and there's multiple relationships between climate and health, and we have a lot to work to try to understand some of these relationships and try to bring in other expertise so that we can better understand this relationship and get out there and actually help save lives moving forward. So with that, I just want to say thank you very much, and look forward to the rest of the panelists. Okay, I got time for one clarifying question, if anybody has one. Nailed it.
Great, thank you. Excellent. Yeah, so now we have our second speaker who's going to talk about water pollution health linkages. So we've had the climate change health linkages. Haven't heard quite enough about irrigation, but we'll discuss that after. But now we'll hear about water pollution health linkages by Dr. Martha Rhoades, who's the research manager at Xenobiotics Laboratory at University of Nebraska. Thank you.
Okay, very good. Thank you. Yes, this was a question that was posed to me and asked. I was invited to talk on this subject, and I said, oh, wow, that's an easy answer. Risk assessment. The easy answer, oh, I want to travel, sorry. The easy answer to this is the difficulty with assessing water pollution and health outcomes is to be able to put our finger on the exposure. Risk assessment, we identify a hazard, and I'm going to share a couple case studies with you today. The toxokinetics and the health effect, we can kind of get that in the laboratory based on animal models. Of course, we can't put our colleagues in the basement and have them drinking any kind of water and further test that, so we use an animal model. In our laboratory, we use a chick embryo model. And then characterizing the risk, that's when we bring in our statisticians and they help us determine if there's a risk associated with the exposure or if there's not. And so we're back to that assessing the exposure. Oops, sorry. So our question is atrazine and nitrate are the two most common drinking water contaminants in Nebraska. So most of my talk is going to be focused on Nebraska. So the question is, does exposure increase risk for adverse health outcomes? So the first thing we did was some ecological work, and we just basically mapped wells that were positive for the two contaminants. So on your left is a map of atrazine, and these are wells sampled, not samples, individual samples, but the particular wells. And on the right are wells sampled for nitrate in Nebraska. And I just want to point out that we used a 2 milligram per liter cutoff because the USGS basically considers anything under 2 milligrams as to be a background level and not really anthropogenic. Anything above 2 milligrams per liter we assume is human contribution to the water. And so we used a database that's been created here in Nebraska, and it is available at CSD. And so we thought, okay, well, maybe because this is the agrochemical contaminant database, that it would be specific to agricultural type wells. And so you can see from the well type figures that there are a lot of irrigation wells here, but there's also a fair number of domestic wells, which means just a private well that folks use as their main source of drinking water. And then there's some public water supply systems here, and as you would expect, the number of public wells is not going to be as high as the private wells that are distributed throughout the state. Then there's that group of monitoring wells where we put down wells where we suspect that there's going to be contaminants, and we take a look at those. So we decided, okay, well, let's take a look at the percent of wells that are positive in each of these categories, and how many of them are positive specifically for nitrate, how many of them are positive for atrazine, and then how many of them are positive for the combination of the two. So that's what you see there on the right. So is this even plausible? Is this just some kind of cockamamie idea that we came up with? Well, it actually is plausible. Nitrate can reduce to nitrite in the human digestive system, and it really likes that pH that's similar to our gut, about 3.5 to 4. And atrazine is a secondary amine, and that poses a favorable chemical to form what we call a nitrosamine. And we already know that many nitrosamines are carcinogenic in animal models. And so that part of it is plausible. There's also been some evidence that suggests that nitrosamines are teratogenic in animal models. So our hypothesis was that the exposure to the combination could be more detrimental to human health than exposure to either contaminant alone. So the first thing we did was we looked at non-Hodgkin's lymphoma. Nebraska has one of the greatest cancer registries around. It's the Lymphoma Study Group. It's housed at UNMC. There was some data that was already collected, so we could perform a secondary analysis on this data. And back in 1996, Mary Ward, I love this paper, she actually autographed it for me, which was very cool. She did a study in Nebraska, and she found that nitrate was associated with risk of NHL. Well, then she just happened to mention to me, but you know what, Martha, I went over to Iowa and I tried to reproduce this study, and I couldn't get the same results. So it got my mind to thinking, oh, maybe it's because there's another contaminant in the water that is confounding her results. So we looked at both atrazine and nitrate, and we found about a 2.5 times risk for NHL for those subjects that were exposed to the combination versus the subjects that were exposed to only one of those contaminants. And then when we further stratified the cancer data to indolent versus T-cell versus aggressive lymphoma, we found an even higher risk for the folks that had indolent form of lymphoma. And in that indolent group of lymphoma is what's known as a follicular lymphoma. It is associated with a certain chromosomal abnormality, and so I'll talk a little bit about next steps with that. So in the meantime, being the toxicologist I am, and knowing that a lot of times lymphoma cancers can have the same sort of mechanism as birth development or embryonic development and birth defects, we decided to start doing a little bit of ecological study on birth defects in Nebraska and some of these positive wells. So what you see here, the dots on the map, are wells that are positive for both nitrate and some nitrosatable agrochemical in the water, and then birth defect rates by county. It doesn't really tell you anything except these counties have higher birth defect rates than some of the others, and there's the distribution of the wells. What we did find was a pretty high correlation between county birth defect rates and the percent of wells testing positive for the contaminants. So the limitations with exposure assessment are many. Cancer has a very long latency period, so you can imagine if you're trying to evaluate someone's exposure who has cancer today, you really want their exposure from 10 to 20 years ago because of the latency period of non-Hodgkin's lymphoma being that long. So consequently, that requires some residential longevity. You want to be able to establish the exposure that they got that long ago. So Nebraskans are a pretty non-transient population, and we could establish, by decreasing our sample size, we could use subjects that had that longevity of 10 to 20 years in the same residence before their diagnosis of cancer. Of course, the water quality data, a lot of times with your public health departments, it doesn't include private well supplies. Those wells are not monitored or regulated under the Safe Drinking Water Act, so you're excluding a whole population there. Some nitrosatable chemicals are not monitored. There's about 30 of those in Nebraska. Many of the Atrazine, for example, has 2 degradant products. Those are not monitored by the Safe Drinking Water Act, so that data is really not available. Birth defects is a little bit easier because one typically thinks that the latency period is going to be shorter. We're not exactly sure, but we're shooting for 3 years before delivery, before conception, as far as the latency period on there. Again, the private well users are excluded from this population, so that poses a limitation on studies like this. Again, the same thing, the nitrosatable agrochemicals that are not monitored. So this just shows you a map to illustrate my point of those nitrosatable chemicals that are not monitored. On the left is all the wells that are sampled, including atrazine. You take atrazine out of the equation, you notice the map doesn't really look that much different. So these other nitrosatable chemicals, they could be confounding our results. So what's next? Well, we have funding to do a pilot feasibility case control study here in Nebraska. Nebraska is a really prime venue for this kind of work. We have A, the disease, and we have B, the exposure, which is required for studies like this. The plan is to recruit 40 Nebraska women, 20 of those who have had a child that's afflicted with a birth defect, and then 20 women who have had healthy children. We want to recruit 5 women who are on private wells, 5 women who are on public water systems, 5 women who use bottled water at a minimum. We've developed a questionnaire to gain information about their demographics and health history. We'll get a water sample from them that we'll submit for nitrate analysis and some of these other agrochemicals, and we'll do a little bit of age dating, well, not a little bit, but we'll age date these samples so that we can tell, oh, this person was probably exposed 50 years ago, 25 years ago. How old their water is will tell us how long the person has been exposed. We'll take a saliva sample from those willing to provide one that will tell us a little bit about their potential for in vivo nitrization, and a blood sample to look at gene-environment interactions. Because the question always for us toxicologists is why are you getting the disease and I'm not? Or why am I getting the disease and you're not? So there's some gene-environment interactions. And just to say that this information is available on a website that we've developed. It's called the BOW Study, Birth Outcomes in Water. You're free to take a look at that. As far as the lymphoma work that we're doing, as I said before, the folks with follicular lymphoma seem to have a higher tendency to have a translocation. It's a genetic chromosomal abnormality. It's called T1418. Our question is, does the exposure have to do with the T1418, or is the T1418 there first, and that leads to the disease? And like I said before, Nebraska is a great venue for these kinds of studies, so it would be really wonderful if we could get a cohort study, which basically you enroll people, they fall into a category of exposed versus non-exposed, and then you compare the two populations to see who acquires the disease and who doesn't. And just to acknowledge the people that have been involved with this, Dr. Spalding, who was instrumental in getting that water quality database going, Jane Meza at UNMC, who's been the statistician on this project from the very beginning, my supervisor, Pat Shea, and then, of course, in memory of Dr. Sidney Mervish, who, without his pioneering work with the nitrosamine research, we wouldn't have even been able to make this hypothesis. Thank you. Oh, okay. I have time for a question. I'm surprised. I thought I was talking over. Anybody with a question?
Good. Yeah, so we have come from climate change to health and from water pollution to health, and now we go towards a more positive linkage, and that's irrigation nutrition. And so we have Professor Martha Mamo, the department head, and John E. Weaver, Professor of Agronomy and Horticulture from Nebraska, University of Nebraska-Lincoln, and she's going to talk to us about irrigation nutrition linkages. Thank you very much.
Good afternoon. So I'm going to switch gear a little bit and talk about insights from work we've done in Ethiopia. Some of the introduction was given this morning with respect to small-scale irrigation or farmer-led irrigation. A little bit of nutrition was touched. So I'll talk about our work, which began in about 2010, transdisciplinary, interdisciplinary work focused on 2 drought-prone areas of Ethiopia, as you see here, the South Wallo, which is in the north-central part of Ethiopia, and then eastern Ethiopia, which also is drought-prone area. Both of these regions are highland areas, high elevation, although there is some stratification in elevation, and I'll talk about that a little bit. In terms of population, they are very dense in population. Each of these regions have about 2.5 million people. Earlier, someone talked about that these spatial unevenness in distribution of population. The other component, livestock, is a high density of livestock. So these cropping systems include cereal crops, but also integrated with livestock. So we had about 340 households, which we did socioeconomic survey. We did some anthropometric surveys as well. And in terms of land size, as you've heard earlier, it's about less than 1 hectare. And again, there's a lot more population or livestock density. In this case, in the south part or the South Wollo part of Ethiopia, you tend to have a higher livestock or TLU compared to the eastern part of Ethiopia. Okay, so Dr. Tadessa spoke a little bit about the survey methodology we did in 2010 and 2011. And so one of the questions in all these households, we asked about shortage of food and coping strategies. And as you could see, over 80% of the population does purchase grain for consumption. And the coping strategies include selling livestock, and that's 50% of the population would sell livestock to buy grain for additional home consumption. That means what they produce is not sufficient to meet their dietary needs. There is also a shortage of food availability. So based on the conversation and the survey information, you could see that in December and later on, up until March, you've got harvest, so there's abundant quantity of food, grain food, so availability and access is straightforward in those months. But what's significant is a shortage of food during the growing season in June, July, August, until you've got the growing season happening, and there's a shortage of food and feed as well. I want to talk about the anthropometric data here. Again, the prevalence of stunting and underweight for ages less than 5 years old. This is a significant issue for Ethiopia. In fact, for these two particular regions, the prevalence of undernutrition is higher than the national average, than the country national average. So these two areas are drought prone and they have a significant undernutrition. So what I want to point out, the three areas here where you see Desi, Kalu, and Talahudri, that's in north central Ethiopia. And then Rhoades and Haramaya are in the eastern part of Ethiopia. In terms of stunting, you could see the most significant severe stunting we see in Rhoades. This is a very highly drought-prone area. It's a district. It has received food aid for over 30 years, and there's frequent recurrent drought occurring in those areas. And the other districts are also have severe drought, but not as significant as Rhoades. And the underweight issue is the same. Again, similar trend with respect to one particular region or district that's severely affected. So I want to talk about small-scale irrigation because 30% of these population or these regions do have irrigation, whether it's traditional irrigation. So the source of water used, over 60% is borehole, well, and surface or river diversion. And then you've got other ways of accessing water. And so you could see this is one example of a borehole, big diameter, storage of water. And so a significant cost to actually access the water. And sometimes these are communally shared water sources. So from this preliminary data in this 30% irrigation, we just compared the anthropometric information about the effect of irrigation. So what we see overall, we don't see a significant effect of irrigation on the moderate and normal growth stunting or underweight in this case. But what we do see, though, what the evidence suggests that when you do have severe underweight, okay, that irrigation, the presence of irrigation actually alleviates that severity. So that's what you see on your right side, where you have irrigation versus non-irrigation, that the effect of irrigation is significant when you have severe underweight or undernutrition. So when we did the survey, again, we had on-the-ground conversation with many of these farmers. And so the basis of what I'm talking about is this idea of understanding farmers' needs, stakeholder needs. And in this particular case, the overarching issue that was pointed out both in group discussion as well as a survey is the need for small-scale irrigation, for irrigation needs. So in 2013-14, we partnered with IDE, International Development Enterprise, which happened to be here for the Water for Food conference. And so we built this coalition and worked with them to develop small-scale irrigation. IDE was already on the ground to work with small-scale irrigation, household-level small-scale irrigation, and these are shallow wells to 20 meters. So we focused on the eastern part of Ethiopia, the two districts that I shared earlier, installed about 38 treadle pumps, drilling and casing and installing and maintenance. And so farmers received training. There was also county extension and district extension people that were involved. So the initial seeding component, one, there was a need that was expressed by farmers. Second, we joined IDE, did the training, and installed these 38 treadle pumps, shallow irrigation wells. So a few years forward, we haven't done the complete post-assessment on the impact of these treadle pump irrigation. However, in the 2 to 3 years post-installation of these irrigation wells, we observed that farmers have made some significant innovation and modification. One, they wanted to decrease their labor. Second, they wanted to increase the discharge. And third, they wanted to reduce the labor associated with pumping water, okay? So we know that production, and it's been documented in the literature, that irrigation increases production, it increases income. In this particular scenario, this diffusion increased to more from 38 pumps, wells to 100, so a very fast diffusion rate. And it was instigated by farmers who wanted to innovate and make things easier for themselves. So it was integrated within their system. And so the additional technology was developed by their farmers. And so it created a business, so to speak, for the young farmers, pointed here, highlighted here in this photo, to actually do entrepreneurial work in terms of adding wells for farmers that didn't have it. So the key part, I think we can make a quantum leap when we say irrigation improves nutrition. So what do farmers, these households, suggest in terms of what they will do if they have an income shift in diet? So vast majority will increase their protein consumption in terms of meat. Okay? I don't see here in their responses a lot of increase in dietary diversity, especially with respect to vegetables and whatnot. So we see a lot of increase in carbohydrate as well as protein consumption. So what I want to point out, yes, small-scale irrigation increased crop production and income for smallholder farmers. Irrigation reduced severe underweight, but not overall undernutrition, and that's a key part. So the research so far has been inconsistent in that space, where small-scale irrigation is not necessarily always correlated with improving undernutrition or decreasing undernutrition. So we need to couple irrigation with nutrition education at different levels. There's going to be a apparent shift in diet, more protein consumption. There's also a need to understand the social cultural acceptance of food types. Okay? So if it's not traditionally consumed, vegetables are not traditionally consumed, that's a big shift from the cereal consumption to a more diverse dietary practice. With that, I want to acknowledge the collaborators and the funding agencies, Water for Food Institute, and the two academic institutions in Ethiopia, Wallo University and Haramaya University. Thank you.
Do we have a quick clarifying question for this talk? Otherwise, we'll move to our solutions panel. And you'll have time to ask questions later, so no worries. Good. So I guess we'll move on to the second part of the session, and we have about 5 minutes each interventions from first Mick Schulte, who is an operations analyst, water in agriculture, global water solutions from the World Bank, and he will directly make, do you want to come here to the, or you want to make your, yeah, just check if the mic works, but it should. Yeah, and so he'll give his perspective, I think more from a developing country context, but about all these talks that he has heard and his own insights. What should we be doing differently going forward? Thanks.
Okay, I'm on, yay. So thank you so much, Claudia. And just to kick things off, I want to say that anything that I've learned about these linkages in the past 2 years really has come from Claudia Ringler herself. So it's really exciting to be up on a panel with you now on this. So as Claudia mentioned, I'm at the World Bank. I coordinate our water and agriculture global work, working with colleagues that work on irrigation across approximately 74 projects totaling about $6.4 billion worth of irrigation that the World Bank finances with its clients. Of that, about 4 million is large irrigation projects, and then the remainder are projects that have other objectives of which irrigation is a part. And I think it's very important in the development context that we distinguish those two, because what might work for large-scale irrigation systems may not work for small-scale irrigation, may not work for farm-led irrigation, and so on and so forth. So there is a diversity there. I'm going to make a timely reference here to the Avengers, since somebody made a Star Trek reference earlier. So the world that we're living in, we're not waiting for the snap. It's almost as if the snap has already happened, and we're figuring out how to get out of that. And the snap in this case is this impact on human health and these linkages. So the World Bank, as part of the Human Capital Project, and if you want to learn more about this, worldbank.org/Human Capital Project. It is a rigorous analytical study that's been conducted across the globe, digging in at the regional level as well. And I don't want to spend too much time talking about the specifics of how the methodologies were done. That's online. But the bottom line picture is, across the world, roughly speaking, it's as if we're operating at 57% of our potential as it relates to human capital. And in sub-Saharan Africa, we're operating at 41 to 42% of where we could be. And those numbers are really staggering. So if you look across the room, it would be as if I directed my attention to just this sliver of the room, and the rest of you all, lovely as you are, don't exist for the purposes of this exercise. There's also 156 million stunted children around the world, and so this is a very important agenda. In terms of solutions, the World Bank and IFPRI have been collaborating on an analytical work that's focused on studying irrigation linkages and water linkages as a whole with nutrition outcomes. And some of these pathways, I'm sure you're all going to be very familiar with. We're focusing on production, on income, on water supply, and on women's empowerment. And there are different indicators under each of those, which Martha touched on very well in her talk. And so the opportunity for us is how do we integrate this practically speaking in terms of solutions? So this could be geographic targeting, so focusing on districts of countries or in basins where the nutrition gap is largest, and also considering water quality. I mean, I don't want to greenwash this. Irrigation linkages with nutrition can sometimes have negative impacts in terms of nitrogen loading, phosphorus loading, et cetera, if that's not managed. So thinking about that as well. Also looking at dietary diversity, looking at, I really want to echo the importance of linking nutrition education with irrigation because there's, I think this moment where you assume, oh, we're growing higher value crops and that's wonderful and therefore we're improving our nutrition outcome and our food security. But if all of those crops are being sold to market for income, which is primarily what they are, you're not necessarily consuming those higher value crops that you're growing, you might be selling them and continuing to eat your staple crops. So just to say that it's not necessarily a one-to-one ratio. In terms of projects, I want to focus on two right now. There's one project in Uganda that focuses on irrigation and climate resilience. And this is primarily an irrigation modernization project, but it has a farmer-led irrigation matching grant mechanism in some of the districts looking at smaller farmer-led schemes. And within this project, doing baseline monitoring of the nutrition situation, but also building in some of these nutrition-sensitive messaging as the project rolls out, building in some of these education programs, taking advantage of other social tools. So for example, using the community center or the meeting where you're talking with all of the farmers, integrating some of those messages into it. So doing that at the beginning of the project so that you can monitor it as the project is going under implementation, because as you all know with irrigation projects, if you're into your 4th or 5th year of implementation and it's a large infrastructure, you've built a bunch of infrastructure, but you haven't necessarily done anything in terms of the food output. The last project I want to talk about in the next 30 seconds is in Somalia, because I think fragility is another really, really important dimension of this conversation, and recognizing that people that are living in fragile contexts are at exponentially higher risks of being exposed to negative nutrition outcomes. And this operation in Somalia is the first of its kind really with the bank, and it's focusing on multiple use systems. And this crosses a suite of solutions using sand dams to encourage water storage, growing fruit trees as demonstration plots for farmers, also looking at other types of what used to be called soft components to build resilience into the system so that it's not just a one-off solution. So I hit my 5 minutes, so I'm sure you'll come back at some point. So.
I think those were excellent points that should help us move forward in the session. We really want to learn, what should we be doing differently as a result of these interlinkages. Great. So we have our last solution panel intervention. That's by Graham Christensen, and he's the president of GC Resolve. And I hope he also tells us what GC Resolve means. And he focuses again we're coming back right to Nebraska, and how we can adapt to climate change and all these challenges that we've heard about here. Thank you, Graham.
Greetings. First of all, a little background. We're going to focus on the solution side with actual practices that we use in agriculture, and our farm and my background all starts from a family farm in northeast Nebraska. This will be a little bit more Nebraska focused than the rest of this, but I think there's principles that apply far beyond our state that I would just love to share. GC stands for Graham Christensen, and Resolve stands for resolving issues. And we also like to say GC stands for grassroots community, because there's a great growing grassroots community becoming more informed and adopting practices by the day. Of course, I don't have to talk much more about the flooding. We're all aware of what happened there. But also the current method in which we're placing various livestock facilities, maybe is something that we should also keep in mind as part of this conversation on how nutrients and contaminants move from point A to point B. Glyphosate, I think most of you are starting to hear a lot about that, but we actually took a little glyphosate test in our family, and I got free packets from somebody that worked at a lab that found favor on me, and 4 out of 6 of our urine analysis actually came up at very high rates for glyphosate. The right is my mother, who eats a more conventional-based diet. The left would be mine. I tend to rely more on organic or know your farmer, and so we're starting to see a correlation that's, I think, more easy to detect today. In partnership with public health and civil engineering, we're also starting to track contaminants in our areas now. There's been a lot of great work been done on this ahead of us, for sure. But the more data and the more people that are informed about this, the better we can address our health issues. And so we're involved in writing a game plan with some of our partners on this. Last year we had 190 participants that participated. Today is the first day of the spring session for this year. And so far we have over 600 participants, so we're definitely picking up the steam on this program. Unfortunately, my home county, there was over 40 samples last year, and the average parts per million in nitrates was at 12.8. So we're going to have to do better with our practices. And then I also just want to talk about, we talk a lot about genetics and technology, but we have to start learning to apply precautionary principle and start looking ahead of what the consequences are before these things just go rampant and cause bigger impacts than we can be able to deal with. But the solution lies in the soil. Through our practices, we can reduce harmful greenhouse gas emissions, and it goes beyond CO2. We can have better water holding capacity, so we can use less water out of the pivot or out of our irrigation systems. And of course, it creates better water filtration, healthy soils, reduced input expenses for the farmers like ourselves, and can also sometimes get us a little closer to value added. Here's a test case. Just right down the road from Lincoln, Nebraska, a little town called Pleasantdale is Del Fike. He transitioned from 7,000 to 700 acres. He found inexpensive ways to be able to grow pasture land and add additional cover cropping into his system. And he was able to raise his organic matter levels in a decade from 2.6 to 6.9% without one drop of synthetic nutrients. And he's also eliminated most of the chemicals as he's starting to get a little trickier with this rotation to ward off the bugs and also reduce his herbicide applications. His soil productivity went up, and so did his profit. This is the most important slide of the whole time. This is starting to lay out what regenerative farming actually is, because I think there's steps to get there. I think there's a lot of differences in what people are perceiving right now, but let's look at this in steps. The very first thing you do is you tip your toe in the water and you start doing the no-till thing, right? A lot of folks have adopted that, but we have to get better. So we add diverse cover crops, which creates more than the polyculture, the monoculture system that we're currently using. We start to create a polyculture. Also gives the farmers more opportunities to have additional market opportunities as well. But this is key. The most key part of this whole system is getting the livestock back on the ground and passing through. Because what that does is it creates the in-farm fertility, our ability to fertilize the land working with nature naturally, which is less expense on the farmers. And then, of course, we add intercropping with trees, which gives us more opportunities for profitability. And as farmers, instead of looking at a linear landscape, we look at this instead, and we see all this more profitability as well as more ability to sink more carbon within our rows. And then, just closing, because I am out of time, degraded rangeland restoration. And so looking at degraded rangeland restoration, that fragile ecosystem just to the west of us in the sandhills, looking at how we can actually augment grazing systems by utilizing this. We've seen great examples in New Mexico, in China, in Kenya, in Mexico itself, and we see how potentially, just potentially in Nebraska, we can fix some of our very fragile ecosystem and some of these great blowouts with livestock and properly using animals within these systems. Thank you.
Yeah, so we've come all back to Nebraska with some great examples on how to manage soil and water and livestock and crop systems in a more integrated fashion. So now I'm turning this all over to the audience because we only have 25 minutes left and we really want as much audience engagement as possible in this session. And if you don't have any questions, I will ask some questions to the panelists, but I hope that you might have some questions. Keep in mind, we're talking about these interlinkages, climate, water pollution, health, nutrition, and how does irrigation help us address these challenges and how can we actually achieve better development outcomes using irrigation slightly differently sometimes as we have done in the past, and in many cases we already, I think, are using it in the right way and fashion. So any questions? It's a pretty broad topic. Any question you might have around this interlinkage set? Thank you. Yeah, please. Maybe just state your name as well.
Sure. Francisco Muñoz Arriola, University of Nebraska-Lincoln. The question I have is for the panelists is they didn't mention explicitly, at least, the role that policies play here. How far we are from developing or designing policies that contribute both to improve the environment, reduce the damages on water quality, and increase the nutrition value of the products?
Mm-hmm. Yep, I think that's a very good question, but I'd like to ideally get one or two more before we're handing this back to a discussion with our panelists. Is that a question coming? Yes, okay.
Yes, hi, Jenny Barron from Swedish University of Agricultural Sciences. And thank you all the presenters for trying to bring in this diversity on looking on issues and opportunities. And I wanted to ask about this dual load to water quality and health impact. So you looked at nitrate and atrazine. I have not seen so many studies that trying to couple two significant pollutants in water and the health implications. So I wonder, do you know if there's a lot of other similar kind of synergistic load studies and health implications? That's one question, because atrazine is actually not used in EU, if I understand correctly, since 2004. And we are just about to phase out the glyphosate, which is a very important weed herbicide for us in our systems. And we're really struggling from a research perspective on what we're going to do with that when that weed killer is out of our farming systems. And the second question was to our last speaker about low and no tillage. Our tillage, low minimum tillage trials, which has been down for 30 years in Sweden, they actually don't really improve the yields. I just wondered if you could quickly let me know if the benefits are completely different than the yield gain, or if there is a yield gain in your Nebraska experience, because then I'll probably have to send some farmers over and learn. Thank you.
Okay, technology transfer, great. So one last question, and then I think we hand over. And two last questions, yeah. So whoever, yeah.
All right. So, okay. Thank you. I'm Noel Aloysius from the University of Missouri. I have a question to the panel. We heard about, say, by 2050, we need to produce this much food for the population, but there is worries about changing climate and weather patterns. We'll have to prepare for that. But at the same time, we also heard about current day issues about cancer prevalence and water quality issues. What should be our priority? We talk about investing of, say, climate change impacts in the future, or what's already affecting, say, my children or my loved ones who are suffering from chronic diseases as a result of degrading environmental quality. What should be our priority?
Yeah, that's a very good linkage question. Trade-offs. Stephanie, please.
Thank you very much for the presentation. Stephanie Morrison from USAID. I had a question related to the Ethiopia study. Looking at the graphic, the irrigation did not have very much impact on undernutrition, yet did for severe undernutrition. Do you have some hypotheses as to why that was seen? Thank you.
Okay, thanks. I think a great set of questions, and I think we have questions for everyone. Do you want to start, Martha, on the chemicals? Yeah, you just have to grab one of these.
Okay, where? There you are. That is a really tough question. There is more interest about exposures to mixtures. Atrazine is one of the oldest used herbicides. So, as I said before, we've identified a few more than 25 agrochemical compounds that have the potential to nitrosate. Did I hear you say something about glyphosate?
Yeah, it's phased out, being phased out.
I would have to look at that structure again. My chemist is here in the room, but I doubt that he will pop up right this second and address that. But I would love to catch your name, and I'm more than happy to share a table of compounds that we're also looking at. Alachlor is one, metolachlor, some of those agrochemicals that are not monitored under the Safe Drinking Water Act here in the U.S. Does that help at all? I'm happy to share a paper that's from the ATSDR, the Agency for Toxic Substances and Disease Registry, where they talk about these mixtures and the potential synergism there. And then, did I answer that question? And I think your other question was directed to someone else. Is that right? Okay, very
good. Yeah, it was a no-till. So maybe, Graham, do you want to take that?
Yeah. So I think the benefits from just no-till on our farm and others, you know, we did it for not necessarily trying to just get a higher profit, although indirectly we get a little bit of an edge there, but it's more for stopping erosion, for increasing water holding capacity. So in 2011 we had a terrible drought, and you know, we had been no-tilling for, I don't know, 6-7 years at that point, and we had a tremendous response compared respectively to other farms in the area on that. And I think for our family, that was when we became a believer. Our organic matters have increased, so the soil has become slightly more productive, and we also have a little bit more drought tolerance. But I think that we have to have a mindset of getting beyond just no-till. I think that we need more biodiversity as part of the operation, and once again, coupled with biodiversity, we need to reintegrate livestock back across the soils as much as we can. And then I think what I'm seeing from folks that have taken these kind of steps is we are getting a little bit more productivity out of there, and we're definitely not expending as much money on the kinds of nutrients that we once did. And systems that are working in this, there's lots of good studies, one out of Iowa State that shows that actually shows that we are becoming a little bit more productive without as much chemical influence. We're talking 80 to 90% reductions according to the Iowa State study, just by getting another rotation, you know, in between that corn and soybean crop. So that's where the real benefits, I think, of that are. And I think the first gentleman was talking about nutrition and soils. The Food and Agricultural Organization says that we have 60 harvests left. I mean, our soil is getting in worse condition all the time globally. And, you know, if we're going to have healthy, nutritious foods, we have to start with healthy soil. And these same kind of practices can help us get to a better place in that sense as well.
Okay, great. So, Martha, do you want to touch on the undernutrition question?
So the question was whether we hypothesize on why irrigation decreased severe malnutrition. Am I correct on that one? Is that the question?
Yeah, no, your results seem to indicate that you see a reduction in severe undernutrition, but not in undernutrition, something like
severe,
that.
Yeah. So We hypothesize that there is calorie consumption. That is one of the key factors, we think, but also access to some protein in terms of milk that could be associated with the reduction in the severe undernutrition. But we haven't dug through, we haven't yet done additional post-assessments on those 38 throttle pumps that diffuse to 100 more throttle pumps in that region. So we have the baseline data where we know where it is, and then we like to measure the post-assessment after several years of small-scale irrigation.
Okay, great. And now we have the two additional questions that I think are directed to everyone. And the first one is, what do we want? I mean, do we want more food or maybe less cancer, whatever, 20 years out in the future, or less birth defects? And obviously we want both. And so the question really is, how can we achieve both? So that's, not only the SDGs, I mean, those are our human development goals, well-being. So we need to produce more food. We have seen severe, not only we have heard this morning that undernutrition is growing, food insecurity is currently going up, it's not going down, which is should be a very big signal that we're not doing things correctly right now, but also, there's more health challenges going forward. So we want to address both, we have to address both. And the question is, how can we address both better? And I think the premise of this session is that we can address things better if we consider these interlinkages. Not only the interlinkages between the fertilizers and the pesticide, but also the interlinkages between health and irrigation and agriculture. So maybe I'll first actually want to ask Mick. So what is your take on the policy side? What policies do we have in place that help us to address these things jointly together? And also, obviously, any specific take on the trade-off question between producing food and staying healthy? Yeah.
So I think starting with the trade-off question, I would, in my response, to reframe it a little bit. Johan Rockström was recently at the World Bank spring meetings, and he showed that famous wedding cake graphic with the SDGs, and the biosphere is at the bottom. That's water, that's land, that's oceans. And so sustaining and securing those resources first before you can get up to the next tier of goals, before you can get up to the next tier of goals. So I think all of these interlinkages, as they go up and down all of these sustainable development goals and all these big questions, the answer is we need to focus on everything, but we need to really target securing the resources at the bottom in order to get up to these higher level goals towards the top. In terms of the policies, thank you so much for that question. Jennifer Serra, who's our Senior Director for Water, will be talking to this policy question tomorrow morning. But this is the big Gordian knot, right? This policy question. On the one hand, you have some countries where they have policies where your maybe pricing is being controlled, or farmers are being encouraged to grow staple crops for self-sufficiency, and that's not necessarily the best solution. I think also these policies between agriculture, between water, right? Securing water, sustaining water, valuing water, policies that do that, policies that work with the irrigation institutions that consider what types of institutional frameworks work best, where can innovation come in? All of these big questions are at policy. And we see a lot of these discussions are happening at large international forums, and that's, I think, really significant in terms of bridging this policy question between the agriculture side and the water side. We all have to have, water and soil are both needed for food, for crops. So bridging that together is the opportunity. I don't have a magic solution. If I did, I would be very, very happy, because we know that science is screaming at us, and it would make our job a lot easier if we knew all of the solutions. But I think continuing to hit our head against that point is so, so important.
Okay, I will give the word to the other panelists only if there are no other questions in the room. We could do another 2 or 3 questions, or we keep discussing among the other panelists these 2 key issues of trade-offs and policies. Are there any final questions from the audience? Is that, there's, okay, one question coming, and then we'll go back and really focus a bit more on the policy and trade-off question. Please.
Yeah, this is Dan Snow, University of Nebraska Water Sciences Lab. I heard this afternoon that education is often viewed as a solution to some of the issues in dealing with malnutrition, with water quality impacts resulting from agriculture and irrigation. Has there been much work done on evaluating the type of education or the actual targets that we need to focus on for education? I guess I have a little bit of interest in that topic, working in an academic institution. I feel like we're not really communicating the right information at the right time to the right people. And I'd like to know what you all think about where we should focus our efforts on in terms of education.
Okay, and then we have Bruce with another quick question.
Yeah, quick question. Bruce Langford, University of East Anglia. It is true that this panel has given us a lot to think about. And so my question is probably quite a difficult one, which is what is the convening frame that we can apply that might bring all of the presentations together? And my tentative answer to that is something along this line of scale, that we've got to think about climate change, irrigation, health, and the landscape through the way we think about scale. How do we, and it come back to the original question on policies, how do we give space to bearing down on some of these problems and therefore solutions through some kind of modularity, some kind of compartmentalization, some kind of way of dealing with this complexity through a more comfortable appreciation of how these become cumulative and emergent from the individual household or person scale right up to the landscape scale. So I'm sort of going along that line, but if you've got more to say on that.
Okay, great. There was one other person who was there and left. Are you still coming back, or just don't want to scare you away? Last question for you.
Yeah. So my name is Bashir Jama, and I'm with the Islamic Development Bank, Jeddah. My question goes actually to the last speaker, the farmer. Really appreciated the transition that you have gone through in terms of improving your soil health, putting in various practices at both the land and the field levels to improve the productivity. One question that came to mind is to what extent have you benefited from policies that supported that transition over the years in terms of buffering you from losses, because conservation agriculture, that doesn't come in easily without certain support. And what messages would you then have related to policies that could help similar farmers elsewhere in Africa, where there's a lot of push, and rightly so, to get in much more, perhaps much more of conservation type agriculture, while recognizing that many of those soils have to be productive, and in many areas they need fertilizers. So what would be your advice for people in smallholders that are into that transition, bearing in mind what you have gone through?
Okay.
Thank you.
Great. Okay, so we'll give 1 minute to each of the panelists to respond to those questions or to the policy or trade-off questions. So do you want to start, Martha? I mean, whichever Martha, actually. Okay.
Can I go back to the cancer and trade-off
Yes,
question?
yes, that's perfect.
Where is that gentleman? There he is. I think I've met you before, actually. So I guess my answer to your question about the trade-offs. Do I worry about cancer, or do I worry about my crops? I am a believer in individualized medicine. I spoke a little bit about salivary nitrate, for example. So we wanted to see if we could estimate a person's salivary nitrate after we had frozen their salivary sample. And what we found out was that people have very different nitrate concentrations in their saliva. So, and we developed a statistical equation that we could estimate what a person's was at time 0 if we froze it for 10 days or whatever it was. And so that worked out very well for us. But the point is that because of the variation among us individuals, you may need to worry about that a little bit more than maybe I need to worry about that. And that is one of the main reasons for us doing this kind of research. Because if you have a tendency to have a little bit more salivary nitrate, let's say, we may be able to come up with a prevention very simple for you that is just based on maybe an antiseptic mouthwash that you use every day. Your genetics, all of our genetics are very important. It may not have anything to do with your exposure, but it may be related to an exposure that your mother had. And so there's the epigenetic component in this evaluation. Okay. So does that answer or not your question?
Probably not, but we have to move on. Please.
I want to address a question related to education. So I believe, let me back up and say a little bit about a few things that I didn't mention. Ethiopia has invested in about 40,000 extension workers deployed to work on reproductive health and nutrition education. So one component is to build capacity in these existing extension workers. But I think it should also be multi-sectoral. That means through the school systems, education, nutrition, the community, as well as the university level to increase the workforce associated with nutrition education. So at the college and university level, increasing that education. So I believe it's multi-level, not necessarily just at the community level, but this addresses the policy component. So Ethiopia, for example, has made a significant move to do agricultural transformation through small-scale irrigation. And the push is to grow horticultural crops. And so what we see when irrigation exists, that farmers are increasing their cropping cycle. And the irrigation is mostly invested on horticultural products or crops. However, these are not necessarily consumed at the household level, they are sold. So the one elephant that we haven't addressed is this post-harvest loss. So you have an increased production of vegetable, but without the value chain and other things, you've got a significant loss in these perishable products.
Okay, great. On to Jesse.
Sure, and I'm going to jump on that education one as well, because I think that is definitely very important. Okay. You know, I really believe is trying to go out and diversify the people that we educate as well. One of the things that we've done recently in the College of Public Health is now students that go through our department or through our program, they have to take a climate change and public health class. And so that's going to teach the next level of experts that are going to be going out there working on some of these issues about the importance of climate change. And the other thing that we're going to try to do is actually go out and start working with medical doctors and trying to get them more educated on this topic as well. Because most people know a medical doctor, most people don't know a PhD. And so how do we get those types of people educated and involved in this as well? I think that that's really important. And I don't want to take up too much time because I know Graham might have some interesting points on policy, so I'll pass it over to him.
On the food insecurity point, just more per acre. Don't just grow linear. Start growing in this whole box up here. That's an important thing that needs to be a part of the education, and also something that has resonated across party lines, across urban and rural, across different kinds of people is soil health. There's a real intersectionality in soil health, and we need to focus ourselves on that. And if we can improve soil health, we're going to get the results we desire in climate as well as in water. And it's probably going to help more farmers have a foot in the door. As far as policy right now, the Farm Bill is tough, somewhat tough on us. It's hard to get into a lot of the conservation programs. There's limitations. A lot of times, programs we tried to get, being a transitional farm, we couldn't even get livestock on the grass we were going to, put in through the conservation title. So that's not working for us. But we're trying to take the situation not into our own hands, but trying to move the conversation quicker in Nebraska. So there's a couple pieces of legislation that are going to help us get there. LB 243 created a soil health task force. That gives us a big forward-looking, long-term picture on what to do. And then LB 729 is a bill I was more involved with. That's called the Soil Health and Productivity Act. And what that does is it targets waterways that are especially the ones coming into the Omaha and Lincoln areas, running waterways. And it says we're going to redivert Farm Bill conservation title funding into the state and administered through the Department of Agriculture, and these funds will be allowed to be able to cover crop 2.5 miles on each side of each waterway. And if it further encourages or gives a higher premium rate for farmers that would apply under this for a multi-species cover cropping. Of course, single species, which comes in a lower rate, can still meet your buffer strip goals. But we need to filter our water, and we need to develop markets for farmers. And that would be a conduit where we could redivert the focus of the Farm Bill and make this easier for farmers to get in a more aggressive path while our Soil Health Task Force continues to search for a big picture that encompasses every farmer and rancher in the state.
Okay, Vic, please.
So briefly, two things. Value the water, sustain the water, and in terms of how do we do this all together, making it accessible in a way that people can actually access, right? Like more people use social media than read reports. So WhatsApp, WeChat, LinkedIn groups, Facebook groups, texting. I don't care what way you do to get your information out, but working across multiple stakeholders, whether it's multi-stakeholder platforms or innovation consortia or trade groups, whatever it is, we all need to make our information accessible and share these stories that are happening on the ground because the youth and the young generations are figuring this out as it's happening. So as those stories go up, that's what changes policies. Actions influence policy. So we need to make sure that we're sharing all of these action stories as we get them.
Great, and just quickly from my side, I think the best framework we have right now are the SDGs because they have all these multiple objectives that have come up here. I mean, climate change, nutrition, health, food security, zero hunger. It's a very complex framework, but we can fit it all what we've talked about here, we can fit it there, and basically you cannot achieve any of these SDG targets and goals without actually acknowledging and working across these interlinkages. So, and in terms of policies and how to do it differently, education, cross-sectoral education. When you do an irrigation project, bring people in the room from the various sectors and then go out, talk to the people, again, who is interacting with them from the different sectors to really lessen the potential negative impacts and increase the positive ones. I think we've heard quite a few examples here where we can work further and with which we can work to start to make a difference on the multiple objectives. So thanks to everyone for coming to this session. So I think we've all learned a lot from this, but you don't actually get a break. So you are invited to the next session, and it's called the Entrepreneurship Marketplace, and it's taking place just now, so it's just starting. You will learn about the latest technologies and startup companies in the High Plains, and their free drinks. So please, that's your next choice. Thank you.